Hello everyone, this is Mr. Mayer, and today's video will discuss parallel lines, specifically using coordinates. For the learning target, at the end of the lesson you want to be able to say, I can create an equation for a line, given one point it travels through and the equation of its parallel line. So we do have two examples to go through. For example 1, the directions say create an equation of a line in slope-intercept form parallel to that equation through that point. So, getting started with this. The nice part about these directions is they're literally helping you. They're telling you what format they want you to write your equation in. All right? So for slope-intercept form, we know automatically we are going to be using y equals mx plus b. Write these things down on your paper. You need to be very well versed with y equals mx plus b. After we've written this, the next thing we want to make sure we understand is we're making a parallel line. Now, the reason that this is very, very helpful for us is that it's giving part of the equation that we are actually going to focus on in order to make parallel lines. These are the things to remember for parallel. Parallel means moving in the same direction. So if I have lines that move in the same direction, they travel together, meaning they have the exact same slope. So the two things you want to remember for parallel lines. Step 1, your slopes must be equal, meaning that you're going to use the exact same slope all over again. And which part here is the slope? It is your m. So you're going to reuse your m when I want to make a parallel line. Okay, so we're going to keep the same m. Step 2, it says the y-intercepts must be different. Your b is your y-intercept. That means this is the part that needs to change. This is the part of the equation that is going to change. In fact, this is the part that we're not sure what it's going to be. So let's see how that's going to look for us. So keep in mind, if we're trying to reuse the same slope, you already know something about your new equation. We want to reuse this part again, okay? Always very helpful, writing the equation first. Now we're plugging in our new values. Well, I know I'm keeping the exact same m, so I'm keeping negative 2/3 as my m. I want to change my b, okay? So I'm no longer going to use this thing yet. I'm just going to cross it right out. It's not part of my new equation. So can I just bring this over here and call it my b? Can I call my y-intercept? Again, this is my y-intercept. Can I just steal it from the given point? Unfortunately, this is not a y-intercept. A y-intercept is only the y value when your x is 0. It's where the line crosses the y-axis when your x is going to be 0, okay? So for this one, I can't just steal this, but in fact, labeling is everything in math. If you label these things, remember this is always x because it comes first, this is always y. Now you realize, oh my gosh, I'm just going to plug in my y value, plug in my x value, and I am good to go. Bring down everything that you have. Again, make sure when I'm bringing these things down, this is my x, I want to put a parentheses around so I remember what to do between these two things. Do I know this value yet? I don't know this. In fact, this is the whole point of this problem, ladies and gentlemen. You are solving for b. You are solving for your y-intercept. Okay, so that's what we're going to solve right now. That's what we're going to work out. You want to use order of operations. Let's see if there's anything we can work out. This is the only thing to work out on this side. These are like terms right now. Invisible multiplication in between the two things. Mr. Mayer, this is where I get lost. It's a fraction times a whole number, an integer. What do I do between these? Ladies and gentlemen, always over 1. Don't forget. Okay, some of you remember cross cancel, and you can cross cancel these two things. I'm just going to go ahead and do the old-fashioned method. When I multiply fractions, we multiply side to side. So I've got negative times negative makes positive. 2 times 6 makes 12. Over 3 times 1 is going to be 3. Bring everything else down. Negative 1 did not change. Equal sign did not change. Plus b did not change. Here, you are ready to simplify anything if possible? I know I can definitely simplify that. 12 divided by 3, I'm just going to write a whole number. It is a whole number. Don't keep it as a fraction. Work with whole numbers when possible. Make it easy for yourself. So I've got -1 equals 4 plus b. Last thing I'm trying to do is isolate my variable, trying to get the b alone. In order to do that, you're doing opposite inverse operations. So I'm going to, instead of adding 4, I'm going to use the opposite of 4, which is -4. Do it to one side. Do it to the other. Mr. Mayer, is this where two negatives make a positive? It is absolutely not this time. What this is saying is I have -1, you're taking 4 away, so you are actually going to grow the amount of negatives you have. It's going to be -5. So -5 equals b, and there you have your variable. So is this finished? It is absolutely not. The whole point was to create an equation. This is the part most people forget. They do such a beautiful job and then forget to put it all together. Remember, write your equation. The equation we used all through the problem is y equals mx plus b. Use it again. So now at this point, I'm writing y equals mx plus b. Plug in the values. I reused my m. You're literally going to plug that right in. This is -2/3. The b you just solved for is -5 or -5. And now, Mr. Mayer, I'm going to go ahead and plug in -6 and -1 for the x and for the y. Here's the problem with that idea. If you plug in x and y, you are only solving for one specific point, literally this one. You're trying to make a line though, okay? So if I'm trying to make a line has to use variables because we want to show every single point on that line is true. Your y stays as a y. Your x stays as x. These are variables. You want to show it's true for every y, for every x on this line. Make that note to yourself. Always keep x and y as variables for your final answer or for the final equation. Now, you saw earlier, we did not keep it as variables throughout. That's fine. But for your final equation, x and y need to be variables. All right, so here's your perfect, beautiful example. You're going to go ahead and you're on your own. Okay, here's example 2. You're going to create an equation of a line in slope-intercept form parallel to, here's the new equation, through this new point. Remember these very important things. Okay, so you're using y equals mx plus b and your 2 steps. Okay, so go ahead and pause the recording. And at this point, you can refer back to the example 1 to help you. All right, ladies and gentlemen, go ahead and check your work. Remember to always write the final equation using x and y as a variable. Okay, the only things you're solving for are the m and the b. So double check. Hopefully you did a nice job. If not, no problem. Go ahead. Math is all about making mistakes and learning from them. Thank you for tuning in, and I will see you in the next video.